Okay, so this is a lecture for AP Environmental that will cover the rock cycle, weathering, and erosion. So the first thing we need to do is define what the rock cycle is. And the rock cycle is basically the breaking down and formation of rock. Okay, so we break down old rock, not we, the earth, breaks down old rock and forms new rock. It's a pretty slow process. It's actually the slowest of all the cycles. You may have heard about 3 different types of rocks that are found on the earth. There's igneous rock, sedimentary rock, and metamorphic rock. Igneous rock is directly made from molten magma, and the magma is the type of liquid rock that is under the Earth's surface, whereas lava is above the Earth's surface. And either one of these things cooling will form igneous rock. Compression of sediments creates sedimentary rock. And sediments can be from parent material like igneous rock, sedimentary rock, or even metamorphic rock. And basically those things break down and form particles or sediments, and then those sediments will compact over time to make sedimentary rock. So sedimentary rock can come from any kind of rock, previous rock. Really quick, an example of an igneous rock is something like granite. Okay, you may have heard of granite countertops. And there's many other types of igneous rock, and you will have to identify a few others. Sedimentary rock, an example of that, is one that's very common in this area, and that is sandstone. Berea used to be considered the sandstone capital of the world, and where Ch8ROCKS Lake currently is actually the remnants of a quarry where they mined sandstone out of the earth at that area. So Ch8ROCKS Lake is not a natural lake at all. It actually is just a water-filled quarry, which really provided the jobs and establishment of the city of Berea. Then there's metamorphic rock, and basically metamorphic rock is any type of rock that is exposed to high temperature and pressure but doesn't totally melt like igneous rock. And an example of metamorphic rock is slate, and they used to make many roofs out of slate. Okay, slate is very heavy. It's very pretty too. And actually another example of a sedimentary rock is shale. And we have a lot of shale cliffs around here in the Rocky River Valley. And shale, when it metamorphoses, when it goes through metamorphosis, meaning in this case high temperature and pressure, it will become slate. So before slate is formed is actually shale. So all of these processes all of these rocks are actually part of the rock cycle. And it's important to make note that erosion and weathering, which we will talk about later on in this presentation, do not produce a type of rock. These are just processes that break down and transport rock particles or sediments. They do not directly produce a type of rock. So it's important for you to know that. What does produce a type of rock is compaction and the cementation of rock to form, so it's not directly from erosion and weathering. Make sure I got all this. Okay. What we're going to do now is actually watch a rock cycle animation, and what I would like you to do is take notes on the animation. What I want you to identify are the events or the processes that actually help to form igneous, sedimentary, and metamorphic rocks. And at some point with this assignment, I would like you to look up some examples of each of those types of rock and record those examples in your notes. Okay, so I'm going to go ahead and click on this animation. So I think I might have it in here. Sorry about the delay. This was the one. I don't know what just happened there. It like paused and then is now like 20 seconds ahead, so sorry for that delay. I'm pretty sure this animation has no sound. So what we have here is igneous rock, which comes from magma. This igneous rock then gets to the surface eventually, and it will weather. And weathering is the breaking down of rock in one place. Erosion, on the other hand, is the movement of those sediments in transport. Those sediments get transported through rivers and runoff into the ocean or nearby body of water, and those sediments are buried and compacted to eventually form sedimentary rock. Okay, let me see if I can go back to that animation because that went really fast. So we'll enlarge this again. You guys can pause and rewind this video, this recording. But again, igneous rock gets exposed to the surface, weathering of the rock at the surface, erosion would then move those particles through the watershed, through rivers. Those rivers will transport those sediments into a larger body of water, and they will be deposited. Over time, those sediments will be compacted. Buried and compacted, and then eventually that will move down into the Earth's asthenosphere and deform and metamorphose to form metamorphic rock. And then that would melt again, and so on. Okay? Again, you guys can watch that video clip numerous times by just simply pausing and rewinding. Okay, the next thing I want to talk about is weathering and erosion. So weathering and erosion, there's a few different types of weathering. There's physical weathering, which is the mechanical breakdown of rocks, and there's also chemical weathering. And the chemical weathering actually involves chemical reactions, and it changes the rock type in the minerals. It dissolves the chemical elements in the rocks and breaks them down, excuse me. It's important to know that chemical weathering is much slower than physical weathering. And there's biological weathering as well. And biological weathering is when life, like lichen, for example, or moss, will grow on a rock as a pioneer species in primary succession and release acids, which could be related to this acid component here of weathering. Not only does life produce acids and break down and release nutrients from rocks, but also a byproduct of the combustion of fossil fuels is the production of nitrous and sulfur oxides, we often refer to them as NOx and SOx. These are both byproducts of the combustion of fossil fuels. And when these two things combine with water, they will make nitric acid or sulfuric acid, which is also known as acid precipitation. And when this happens, those acids will react and react with water, obviously, and then form acid rain. But then that will affect rock as well. So as that acid rain comes down, it will dissolve and chemically react with the elements that are in rock and form new compounds. Okay. The next thing I have are some pictures right here. This is actually a picture of a rock that is being oxidized. So it has some metal components in it, some metals, and the metals react with water and oxygen and oxidize to form rust. So a lot of times you'll find rocks that actually have like natural rust on them. This is a picture of lichen that is growing on feldspar, which is a type of igneous rock, I'm pretty sure. And the lichen is chemically breaking down the rock. It's changing the rock. This is a picture of physical weathering. So sometimes rocks will be split by life, and it doesn't change chemically, it just changes physically. Okay? And then one thing I want to make note of is the fact that you know the difference between erosion and weathering. In this picture here, it shows weathering, which is the breaking down of rock, and it stays here. Okay? Whereas erosion will transport and move the sediment to another place. Okay? So that's that. And one of the things that we're going to be talking about later on in the week is soils, and the fact that we are losing our topsoil at a rate that exceeds formation. And erosion is the biggest problem. So we've got erosion, we have soil loss as pictured in this right here, and that is a big problem in our waterways and our medium with which we grow our food. So it's important that we decrease erosion to decrease soil loss. And so we'll learn about a number of methodologies in farming and land use practices to help reduce erosion and therefore decrease soil loss and also improve water quality. Remember, sediments are the number one pollutant in our waterways. So there's a way we got to bring that back, and we'll talk about that at a later time. And that's the end of this lecture.